In this section, we're going to start doing a little introduction to the world of Kubernetes, first beginning by answering two very important questions. First off, what is Kubernetes? Secondly, why would we ever want to use it? Now we're going to try to answer both these questions at the same time inside this section, so let's get to it. All right, so to begin, I want you to think back to the Elastic Beanstalk application that we just put together. Inside that application, we had 4 different containers running at the same exact time. We had Nginx, which was forwarding traffic to our server and our client, and then behind the scenes, we kind of had that worker process running as well. And of course, we had a copy of Redis and Postgres running as well, but those weren't really containers that were running with the rest of all of our other containers as well. They were outside services. Now, I want to think about this application, and I want to ask you a very simple question. How would we scale up this application? In other words, if we started getting a lot of traffic and we started having a lot of different users starting to enter in different numbers to calculate the Fibonacci sequence for, how would we kind of respond to that? Well, if I had to take a guess, I would say that it would probably be this worker container over here that was doing the absolute brunt of all the work inside of our application. In other words, this worker process was using an algorithm for calculating that Fibonacci value that was very inefficient. And we very purposefully left it kind of inefficient just to see what would happen if it took a long time for that particular container to get some work done. And so if we started having a lot of users making use of our application, the most critical part to make sure that this thing was working correctly or the entire application was working correctly would have been this worker container over here. Now, ideally, what would have been really nice is if we had some way to easily spin up multiple processes or multiple containers of that worker image. And so if we had like 3 users come into our application at the exact same time, it would have been great if we had 3 different workers, one of each could have been used to create or to calculate a different Fibonacci value. However, this would have been rather challenging to do in the world of Elastic Beanstalk. You see, in order to scale an application by default with Elastic Beanstalk, here's what actually happens behind the scenes. So this is the typical scaling strategy for Elastic Beanstalk. Rather than creating more copies of a single container, Elastic Beanstalk looks at that docker run.aws.json file, and it spins up additional copies of the entire set of containers. In other words, we can kind of imagine that to scale up our application, Elastic Beanstalk would have created maybe 2, 3, 4, 5 different sets of all of our containers. Now, unfortunately, we don't really have a lot of control over what each of these different groups of containers are doing. In other words, on each of these different groups of containers, we got an additional copy of Nginx, an additional copy of the server, and an additional copy of the client. But at the end of the day, chances are that the Nginx or the client or the server images or containers that we were running were not going to be really the limiting factor of performance inside of our application. Like we just discussed, it was the worker container that was the limiting factor. And so it would have been way more ideal to scale our application if we had the opportunity to do something a little bit more like this. Let me show you. It would have been just great if we had the ability to spin up these additional machines and just create a ton of additional copies of that worker container on each one. Chances are we didn't really need multiple copies of Nginx or the server API or the client. They were all relatively simple, and for the most part, we're just kind of serving up flat files or responding to very simple API requests. It was only the worker container that was doing some major computational work inside of our application. And so it probably would have been ideal if we could have done something like this instead. So, as you might imagine, this is the type of approach that Kubernetes would allow us to have. If we were making use of Kubernetes, we could have had additional machines running each of our containers, and we could have had a lot of control over what these additional machines were doing or what containers they were running. So let's take a look at a quick diagram of how Kubernetes could have been used to solve this entire scaling issue. So what you see on the screen right here is a diagram of a very simple Kubernetes cluster. A cluster in the world of Kubernetes is the assembly of something called a master and one or more nodes. A node, which is each of these blue boxes right here, are a virtual machine or a physical computer that is going to be used to run some number of different containers. So each of these different virtual machines or physical computers that you see right here can be used to run different sets of containers. I want to be really clear that each of them can run different containers, like different images, or even different numbers. So for example, the node on the far right-hand side over here is running 3 separate containers, and the one in the middle is running just one container. These can be completely different containers. They don't have to be identical. And so in the world of Kubernetes, you can imagine that we could have very easily gotten closer to a kind of scaling flow like this right here. Or maybe we had just one node or one virtual machine that was running Nginx, our server and our client, and then maybe we had a bunch of additional nodes or virtual machines that were running copies of our worker image. Now in the world of Kubernetes, all these different nodes that get created are managed by something called a master. This master down here has a set of different programs running on it that control what each of these different nodes is running at any given time. You and I, as developers, interact with a Kubernetes cluster by reaching out to this master right here. You and I give some set of directions to the master. For example, we might say, hey, please run 5 containers using the client worker image. The master receives that command and then ultimately relays that command to all of these different nodes. Now, outside of our cluster, which is represented by this gray block box right here, we have a load balancer, which will take some amount of outside traffic in the form of network requests and relay all those requests into each of our different nodes. Now, one thing that's going to be a big point of discussion for us is exactly how this node balancer works. And so that's going to be something that we talk about inside of the next many videos on Kubernetes that we're going to go through as well. Okay, so in this section, just a very high-level discussion on Kubernetes and what it is and what it does for us. So at this point, I think we've kind of established that Kubernetes is a system for running many different containers, so different types of containers, different numbers of containers over several different computers or virtual machines. And we would choose to use Kubernetes if we had the need to scale up our application and run multiple different types of containers in different quantities. If we only wanted to have a system where we essentially ran, let's go back way over here. If we ran the same set of containers over and over again, like you see right here, not a lot of good reason to use Kubernetes. Again, we want to use it anytime we expect to have an application that consists of many different types of containers running in different quantities on multiple different computers. All right, so with all that in mind, let's take a quick pause right here and continue in the next section.